students, now let's understand next question. Again, in this particular question, I want to find the centroid of the composite shape. Observe what standard shapes are involved. You can very easily understand that there is a big rectangle first of all, isn't it? This rectangle is there. Then along with the rectangle, you can see a semicircle, the second standard shape, rectangle, semicircle. You have a quarter circle which needs to be removed, and finally you have a right angled triangle. So here the first one is a rectangle, the second one is a semicircle, a quarter circle, and fourth one is a right angled triangle. So there are four standard shapes involved into this particular composite shape. So let's begin with the very first one, the most simplest one. Obviously it is a rectangle. You can observe that the rectangle is kept in the first quadrant, isn't it? Then you can see that the semicircle also in the first quadrant, the quarter circle also in the first quadrant, but I'm going to consider quarter circle at the end because from the entire composite shape, I want to remove the quarter circle. Quarter circle needs to be removed. That means its area is going to be negative. So that will be my fourth shape. So the very first one I'm going to consider with the rectangle. So let's take the very first standard shape, students, here. That is a rectangle. You can easily observe that this rectangle has both the adjacent sides along the x and the y axis. And let's understand the dimensions also. If you look at the width of the rectangle, it is going to be 9 centimeter. That's 3 centimeter plus 6 centimeter. So that's 9 centimeter. And students, if you observe the depth of the rectangle, it is same as the diameter of the semicircle. Radius is 2.5 centimeter. So the diameter becomes 5 centimeters. So it is 9 by 5, isn't it? So let's draw the first standard shape, which is a rectangle. I take the x-axis, the y-axis, and let's draw a rectangle such that its dimensions are 9 centimeters by 5 centimeters, isn't it? Now we all know that a rectangle is a symmetric body, isn't it? So you should be definitely having the lines of symmetry. So you will get two lines of symmetry, and the intersection of the lines of symmetry is going to be the centroid of this particular diagram. So let's say these are the lines of symmetry. So that becomes the centroid. I call it as G1. So this is a line of symmetry, and is the other line of symmetry, isn't it? So let's write it out over here that these are the lines of symmetry. Now I want to locate the coordinates of the centroid with respect to the original x and the y axis. So I will be considering the distance of the centroid from the y axis. So this is the distance of the centroid from the y axis. That becomes the x coordinate. So that is x1 bar, and likewise you have the other distance. This is y1 bar. So I have x1 bar and y1 bar. It is very simple to understand here. This x1 bar is basically going to be, if I call this 9 centimeter as b, so this is b upon 2, and if I call the 5 centimeter as d, so this distance of y1 bar is simply going to be d upon 2, isn't it? So you can observe x1 bar is same as b upon 2, y1 bar is same as d upon 2, and the entire standard shape is lying in the first quadrant. So both x and y coordinates are going to be positive. So very first I'll write the area. So students, let's write the area. So A1 is going to be B into D. So B is 9, D is 5. So that's 9 into 5. Of course, this is oral calculation. You can easily do it. 45 units are centimeter. So I write 45 centimeters square. So that's A1. Now let's get X1 bar, students. X1 bar is going to be what? X1 bar is going to be B upon 2, isn't it? So X1 bar is B upon 2, and I know B is 9, so I get 9 upon 2, or I can say this is 4.5 centimeters. So I've got X1 bar value. Now let's get the value of Y1 bar. So Y1 bar is going to be D upon 2. So D is how much? It is 5 centimeters. It gets divided by 2. So I get 5 upon 2, or I say 2.5 centimeters. So that was all about the very first standard shape, which was a rectangle. I've got A1, X1 bar and Y1 bar. Now the second standard shape that I'm going to start with is the semicircle, and the third standard shape will be right angle triangle. So second standard shape, semicircle, where is it kept? It is kept at a distance of 9 centimeters from the y-axis. Observe carefully. This semicircle has the diameter. You can see that this CD. What is CD? CD is the diameter of the semicircle. And how far is this diameter? It is at a distance of 9 centimeters. So you should draw exact diagrams while considering the standard shapes. So the second standard shape, it is the semicircle, isn't it? And you can observe with respect to the x and the y axis, what is its position. So this x axis, y axis I have drawn. So the diameter is at a distance of 9 centimeters, 3 plus 6, 9 centimeters from the y-axis. And what is the radius of this particular semicircle? So this semicircle has radius 2.5 centimeters. So let's write the details. I can say that this semicircle has radius 2.5 centimeters. This line has become the diameter and it is at a distance of 9 centimeters from the y-axis, isn't it? Now, look at the center, students. This is the center of the semicircle. Now, what is the distance of this semicircle? You can very easily understand. The distance of the center for this semicircle is going to be same as the radius, isn't it? Radius is 2.5. So this distance is 2.5 centimeter. Now, can you say that the semicircle is a symmetric diagram? We all know it's a symmetric diagram. It will have a line of symmetry. This is the line of symmetry, isn't it? This is the line of symmetry. Now, I know that the centroid for a semicircle will always lie on the line of symmetry and it is at a distance of 4r upon 3 pi from the diameter of the semicircle. So, I am going to locate the centroid. So, let us say this is the centroid. I call it as G2. So, the distance of this centroid is how much? It is going to be 4r upon 3 pi, isn't it? 4r upon 3 pi from the diameter. Now students, I want to locate x bar and y bar, which are the distance from the y-axis and the x-axis. So look at this. This is the centroid, isn't it? This is the centroid G2. So its distance from the y-axis. This becomes the distance from the y-axis. This is the perpendicular distance from the y-axis. This is going to be x2 bar, isn't it? Now students, observe carefully what is x2 bar here. x2 bar, is it nothing but 4r upon 3 pi? No students, it is not 4r upon 3 pi. 4r upon 3 pi is just the distance of the centroid from the diameter, and the diameter is kept at what? It is kept at a distance of 9 centimeters, isn't it? So now I can say that x2 bar is actually 9 centimeters plus this 4r upon 3 pi. Further, where is the diagram lying? The diagram is lying in the first quadrant, so I'm least concerned about the signs because the signs for the centroid x and y coordinate are going to be positive. So let's first of all get area. So I'm going to write area over here. So this is A2. It is a semicircle, so we know the formula. It is pi r square upon 2. What's the radius? It is 2.5, or you can say 5 upon 2. That is also okay. So I can write this is pi into 2.5 square divided by 2. I know 2.5. The square of 25 is 625. So the square of 2.5 is going to be 6.25. So I write here this is 6.25 pi upon 2. You can still proceed further. You can still simplify it further. So you can cancel this 6.25 with the 2. So I get 2 3s are, that's 6, isn't it? Then 3 point, that's 2. So 2 1s are 2. So I get 1. Then there is 5. So 2 2s are 4. I get 2 and then 5 pi centimeter square. So students, that is a value of A2, isn't it? I've got A2. Now I'm going to get x2 bar and y2 bar. Now observe, I want to get y2 bar. So this is the distance of the centroid from the x-axis. So that's y2 bar. So y2 bar is going to be same as the radius, isn't it? It is going to be same as the radius. So let's first of all write x2 bar. So what is x2 bar going to be, students? x2 bar is going to be 9 centimeters, isn't it? 9 centimeters plus what distance? Plus 4r upon 3 pi plus 4r upon 3 pi. So it is going to be 9 plus the radius. The radius is 2.5. So that's 4 into 2.5 upon 3 pi. So you should definitely simplify this particular value. Getting or not? So let's simplify this value in a moment. Let's get y2 bar also. What about y2 bar? Y2 bar is same as the radius, which is 2.5 centimeter. So I write here 2.5 centimeter. Now I need to get the value of x2 bar. So let's make use of the calculator to get the value of x2 bar. It is going to be 9 plus 4 into 2.5 divided by 3 pi. Students, the answer is coming 10.06103295. So I can simply write the answer as 10.061 centimeters. Getting or not? So that's x2 bar. So I've got my value of x2 bar. Now, once I've got a2, x2 and y2, now I need to proceed for the next standard shape, isn't it? So students, the next standard shape, I'm going to consider the right angled triangle. I'm going to consider the quarter circle, which is in the first quadrant, but I'm going to still consider it at the end. The reason for this is this particular standard shape needs to get removed from the composite shape. The semicircle, the quarter circle needs to be removed from the entire composite shape. So its area is going to be negative. So let's keep it for the end. So now I'm going to start with the third standard shape, and the third standard shape is the right angle triangle. You can observe that the right angle triangle is kept in the fourth quadrant, isn't it? It is in the fourth quadrant. So accordingly, the coordinates of the centroid are going to change. So let's take the right angle triangle. So my third standard shape is the right angled triangle, isn't it? So for this right angle triangle, which is in the fourth quadrant, look at the height. It is 4.5 centimeter, and if you look at the base, it is 3 centimeters. So it's 4.5 and 3 centimeters. So I can now have the fourth quadrant. So there is this x-axis, then you have the y-axis, isn't it? I've drawn the fourth quadrant, and in this I'm going to take the right angled triangle. So let's take the right angled triangle here. It's 3 centimeter and 4.5 centimeters. The height and the base, isn't it? So that's the origin O. This is 3 centimeters. This is 4.5 centimeter. Be very careful with the location of the centroid. The centroid is going to lie in the fourth quadrant, and whenever a point is in the fourth quadrant, its x coordinate is going to be positive and the y coordinate is going to be negative. Further, I know for a right angle triangle, the distance of the centroid is always 1/3 distances of the perpendicular sides. So you have this 4.5 centimeter or this 3 centimeters. So draw lines such that they are at 1/3 distances from the perpendicular side. So I'm going to call this 4.5 centimeter as H. So this is H, 4.5 centimeter, and this is B, which is 3 centimeter. So you can easily understand that the location of the centroid, this is G3. So this distance of G3 from one of the perpendicular side is 1/3. That's B upon 3, isn't it? This distance is B upon 3. Likewise, students, you can say that the distance of the centroid from the other perpendicular side, this is again going to be 1/3. So that's H by 3, isn't it? So you have B by 3 and H by 3. Now, students, very beginning, we will first get the area. So let's get the area. So I'm going to get the area A3. I know the area for a right angle triangle is half into the product of the perpendicular side. So I write half into product of perpendicular sides, isn't it? So who are the perpendicular sides here? So that's 1 upon 2 into 3 centimeter and 4.5 centimeters. So I write 1 upon 2 into 3 into 4.5. Into 4.5. So if you want, you can proceed further with the simplification part. So you get this 3 and it gets divided by 2, you get 1.5. So you have this 1.5 into 4.5. It's like 15 getting multiplied with 45. So 15 5s are 15 into 5 is 75. So 5 carries 7. 15 fours are that's 60, and the carry 7, it becomes 67. So I write 675. Then you need to put the decimal after 2 digits, isn't it? 0.5, 0.5. So 6.75 centimeter square is the area of the right angle triangle. Now let's locate the centroid. So I'm going to get first of all x3 bar, isn't it? Let's get x3 bar. So you can observe that x3 bar is the distance of the centroid from the y-axis. Distance of the centroid from the y-axis. So that's x3 bar, and you can have the distance of the centroid from the x-axis, that's y3 bar. So what is x3 bar? It is directly b upon 3, isn't it? And since it is the fourth quadrant, x coordinate is going to be positive. So x3 bar is going to be b upon 3. So that's 3 upon 3, which is 1 centimeter, isn't it? So x3 bar is 1 centimeter. Likewise, students, now let's get y3 bar. So y3 bar is going to be h by 3, isn't it? Directly it is h by 3. So what is h? It is 4.5 centimeters. So I write 4.5 upon 3. It comes out to be 1.5 centimeters. So I've got the third standard shape, which is a right angle triangle. Now let's move on ahead with the fourth standard shape, students. The fourth standard shape, now I'm going to consider the quarter circle. Now why it is considered fourth? Because its area is going to get removed. The area is going to be negative. So the fourth standard shape, which is a quarter circle, lies in the first quadrant. That means the coordinates of the centroid are definitely going to be positive. So now let's take the fourth standard shape, which is a quarter circle. So students, what is the position of the quarter circle? Observe carefully. If you see the quarter circle, it's one of the radius is lying along the y-axis, and the other radius can be said at a distance of 5 centimeters, isn't it? This is 5 centimeters, and one radius is directly on the y-axis. So here I'm going to draw the quarter circle in such a way that it lies in the first quadrant. So this is x-axis, this is the y-axis. One of its radius will be directly on the y-axis, isn't it? And this distance is 2 centimeter. This is 2 centimeter, and then you have this 3 centimeter. So I'm going to take the quarter circle somewhere here such that the radius is 3 centimeters. So that's the quarter circle that I've made. This is the quarter circle, students. Now, first of all, you tell me what is the total distance here. This total distance is how much? It is 5 centimeter. This quarter circle has what radius? Its radius is 3 centimeters, isn't it? Radius is 3 centimeter. This total distance is 5 centimeter. Now further, I know that for a quarter circle, the centroid is going to lie at a distance of 4r upon 3 pi from the radius. So these are the radii, isn't it? So distances you should be taking 4r upon 3 pi. So that's your centroid G4, isn't it? Now let's locate the distances first of all. So this distance of the centroid from one of its radius is 4r upon 3 pi, isn't it? That's 4r upon 3 pi, observe carefully. Whereas this distance of the radius is also going to be 4r upon 3 pi. So let's look at it here. So this is 4r upon 3 pi. Always remember, location of the centroid with respect to the standard shape, you have to memorize these formulas. So it is always at a distance of 4r upon 3 pi. So these distances is 4r upon 3 pi. That's 4r upon 3 pi. This is 4r upon 3 pi, isn't it? Now I need to locate the coordinates of the centroid with respect to the original y and the x-axis. The distance from the y-axis becomes the x coordinate. Distance from the x-axis becomes the y coordinate. So students, now I have this G4. This is going to be the x coordinate, isn't it? It is a distance of the centroid from the y-axis. So this is going to be x4 bar. Likewise, students, the distance of the centroid from the x-axis is going to be y4 bar. Now look at this. X4 bar, if you observe, it is nothing but 4r upon 3 pi itself, isn't it? X4 bar is 4r upon 3 pi. But look at y4 bar. Y4 bar is not 4r upon 3 pi. It is going to be this 5 centimeter, whatever length you have here, 5 centimeter minus the distance of 4r upon 3 pi, isn't it? So to be very careful while writing the coordinates of the centroid. Now, the very first thing, I should always write what? I should always write the area first of all. So the very first thing I'm going to write is the area. So let's write A4. It's a quarter circle. I know the formula is pi r square upon 4. What's the radius here, students? The radius is 3. So I'm going to write r as 3. So I get pi into 3 square upon 4. So it simply becomes 9 pi by 4 centimeter square. That's the area for the quarter circle. So that's A4. Now likewise, let's get X4 bar. So X4 bar is simply 4r upon 3 pi. So I write here X4 bar. It is 4r upon 3 pi. And I know that the radius is how much? It is 3. The radius is 3. I know the radius is 3. So this radius and this 3 will get cancelled. You get 4r. You get 4 upon pi centimeters as X4 bar. Now I've got X4 bar, students. Now I need to get Y4 bar. Observe carefully, Y4 bar was not 4r upon 3 pi, it was 5 centimeter minus 4r upon 3 pi. So I get Y4 bar as this distance 5 centimeter. So I write 5 minus 4r upon 3 pi. Again, I know that the radius is 3. So this radius and 3 will get cancelled. So I simply need to do 5 minus 4 upon pi. So I'm going to get this calculation in a short while from now. But before that, students, I know that if I want to find the centroid of the composite shape, I have the formulas. X bar is equal to what? It is summation of AI xi upon summation of AI. So I write here X bar is equal to summation of AI xi upon summation of AI. And what can you say about Y bar? Students, Y bar is going to be summation of AI yi upon summation of AI. So you can observe this is a standard technique of solving the question. You need to find summation of AI for both finding X bar as well as Y bar. That means you should also get summation of AI over here. Now, the areas which we are going to keep will be positive. The areas which we are going to remove will be negative. So let's get summation of AI also, so we can do the calculations simultaneously here. So I'm going to get summation of AI and then I will get Y4 bar also. So summation of AI is going to be A1 plus A2 plus A3, and students, I get minus A4 because you need to remove the quarter circle, isn't it? The quarter circle needs to be removed from the diagram. So A4 is going to be negative. So what's A1 that you have? A1 is 45 centimeter square, 45 centimeter square. So A1 is 45 here. What about A2, students? A2 is 3.125 pi. So I write here 3.125 pi, then plus, what about A3 value? The A3 value is 6.75, isn't it? So A3 is 6.75. And finally, I'm going to subtract the A4 value. A4 value is 9 pi upon 4. So I write here 9 pi upon 4. So I'm going to get summation of AI as well as Y bar. So let's get both the calculations together. Let's make use of the calculator. So I have this summation of AI. Let's get that value first. So it is 45 plus 3.125 pi plus 6.75 minus 9 pi upon 4. So my answer that is going to come here is 54.4989. 54.4988. So this is approximately equal to 54.5 centimeter square. That's the value of summation of AI. Let's get Y4 bar also, students. I need to do 5 minus 4 upon pi, isn't it? So let's do 5 minus 4 upon pi. So my answer here comes out to be 3.72676. So I write here Y4 bar as 3.72676 centimeters. So students, over here you need to understand that only for the right angle triangle. Observe carefully. For the right angle triangle, what has happened? I have done a very small mistake over here, and that mistake is for the right angle triangle, y3 bar is going to be negative. So can you understand there can be a big blunder if you do not pay attention. So here y3 bar for the right angle triangle is going to be coming with a negative sign. So I should take care of that, isn't it? So y3 bar is going to be minus h upon 3. So that's minus 4.5 upon 3. So minus 1.5 centimeter. So this is very important, isn't it? So students, you got to pay proper attention that for a right angle triangle, I have done a small change. A negative sign has been put up for the y coordinate. So far what we have done, students, so far we have understood how to find the centroids of all the standard shapes, and then we have also got the areas. Now these two values I'm going to take and go to the formula for x bar and y bar. Students, now place all the values. Now we have A1, X1 bar, Y1 bar, A2, X2 bar, Y2 bar, A3, X3 bar, Y3 bar, and A4, X4 bar, and Y4 bar. So I'm going to make use of these values in the formula here. So I should be very careful here. So summation of AI into Xi, only the fourth area is going to get negative. So here A1 into X1 bar, so that's 45 into 4.5. So I write here 45 into 4.5, the first value, isn't it? Then plus A2, that's 3.125 pi into X2 bar, which is 10.061. So that's A2 into X2 bar. So I can write plus A2 is 3.125 pi into 10.061. So I write here 10.061. That's A2 into X2 bar. Then I do plus A3. A3 is 6.75, isn't it? Into X3 bar, which is 1. So I simply get 6.75. So 6.75 into 1. Be careful. There is a negative sign now because the fourth area will get removed. So that's 9 pi upon 4. That's the value of A4. You can observe that it is 9 pi upon 4. So I write here 9 pi upon 4. It multiplies with X4 bar, which is 4 upon pi. So I write here 4 upon pi. Let's do the simplification. Very easily you can observe that the pi and the 4 can be cancelled. So this is the power of not doing the calculation at that particular point over there, isn't it? You can find that a lot of things can get cancelled if you keep the terms as it is. And this, students, this gets entirely divided by summation of AI, which is 54.5. So I'm going to write here 54.5. So I'm going to do the calculation in a short while from now. Let's write the calculations for y bar also and then do the calculations both of them together. So I'm going to get y bar here. Let's get y bar. So y bar is going to be A1 into y1 bar. So that's 45 into 2.5. I write here 45 into 2.5. Then you have this A2, which is 3.125 pi. So that's plus 3.125 pi multiplies with y2 bar, which is 2.5, isn't it? So that's 2.5 over here. Then plus the next area, which is 6.75. Now be careful, y3 bar was negative, so the negative sign has to be taken very carefully over here. Otherwise, everything will go wrong. So that's 6.75 into the y bar coordinate, which is minus of 1.5. Then again a negative sign, students, isn't it? Because the fourth area needs to be removed. So minus, what is A4 here? It is 9 pi upon 4. So that's 9 pi upon 4. This multiplies with y4 bar, and y4 bar value is 3.72676. This is going to get divided by the area, which is 54.5, isn't it? So now I'm going to do the calculation. So let's take the help of a calculator. What do we have? We have 45 into 4.5. So 45 into 4.5 plus 3.125 pi multiplies with 10.061, isn't it? Then plus 6.75 into 1, that's simply 6.75, minus pi, 4 pi has cancelled, only 9 has been left. 9, so that's the entire numerator. You'll get some answer. It is 299.0236 and so on. This gets divided by 54.5. My answer, students, comes 5.48667. So I'm going to write my answer for x bar. It is 5.48667 centimeters. So that's the value of x bar, students. I've got the value of x bar, and now I will do the calculations for y bar. So let's do the calculations for y bar. So for y bar, it is 45 into 2.5. So that's 45 into 2.5, then plus 3.125 pi multiplies with 2.5, isn't it? Then a negative sign is going to come. You have to be very careful. Minus, you get 6.75 into 1.5, and finally minus of, you have 9 pi gets multiplied with 3.72676 gets divided by 4. You get some answer. It is 100.57577. This needs to be divided by 54.5. Your answer is coming 1.845427. So right answer over here, it is 1.845427 can be written as 3 centimeters. That's the value of y bar. So students, again in this particular question, what things have we seen? Again, there were some standard shapes involved. Some part was in the first quadrant, some part has gone into the fourth quadrant, and accordingly, I have located the centroid of the entire composite shape, isn't it? So I guess now these many questions are that were taken, which were based on the direct application of the formula, are more than enough to understand the concept of centroid. Now we are going to move ahead with some more important questions where the entire diagram will not be in the first quadrant. We are going to make use of a concept called as shift of origin to understand those particular questions. So students, that was all about this particular question. We are going to proceed ahead with the next question now.